stránkách.
Jsme na stránkách. Myslím, že můžeme. Tak to obejdi dobře.
Děláme nějaký soundcheck nebo něco takového?
Já zavolám Kláře a kdyby to bylo špatný, tak ti řeknu jinak normálně.
Tak to zavolej Kláře a já dělám soundcheck, ona ti dá zrovna vědět telefonu, jestli slyší.
Tak ty musíš na věci, prosím.
Soundcheck. Soundcheck.
Funguje zvuk všechno, ne? A vidíme, jo.
Hello everybody and welcome to Furch Guitars, to Czech Republic, to Velké Němčice, here where all our Furch guitars are built. I am Peter Furch and in next roughly like 60 minutes I would say I will walk you through the process of how our guitars are built. First of all, but I would like to wish you all the best if you are at home, if you are in quarantine or have to stay at home. We think of you, and I wish to all of us that we will overcome this kind of situation and strong and with this all together. So let me show you this room. This room where we are right now, this is where our heaviest machinery is, and we produce necks here. There are some very interesting features about Furch necks, and I would like to explain those. But for that I have to explain how the neck of the guitar actually works. So here is a truss rod. Truss rod is basically a piece which is in every guitar neck. All manufacturers use similar system or even the same system. So this is the truss rod which you fit in the neck, and then by turning this screw, you will you basically bend the neck towards concave or convex direction in order to achieve the great neck relief, which is important for your playability. Now, the problem we were having, and basically what all the manufacturers are facing, is if you fit it in the neck, into the wood, then you basically, and starting the turn, you basically apply the tension only at the beginning and at the end of the truss rod. And what happens between those 2 points, is basically depends on the wood, and wood is natural material. It's quite unpredictable, and it has some sort of like a tensions inside, which you cannot get rid of even with a good curing, good drying. So it develops, it can develop some sort of like a twist or humps, and this is something which you don't want on the fingerboard. And therefore we are thinking how to make basically neck behave as much as we want. So what we did is we put this truss rod inside of the carbon pipe. You see, this is the carbon pipe. Now, when I start to turn this screw, the truss rod will apply its tension on the beginning and at the end of the carbon pipe. But it basically, because the carbon is very rigid, it will bend very smoothly. It makes very smooth neck relief. What is another element of this of Furch system is that there is this cast element. Which we put here like this. This is basically metal part. It's cast element, and its job is to basically hold the tension of the strings. And the strings actually, what on the guitar at this point, you have to imagine there are 72 kilograms of the tension. So this neck joint is basically under big pressure, big tension. In order to hold it by wood itself, we would have to have a big block inside of the guitar body, which is muting the resonance. So we didn't want to do it. We were basically, that's why we decided to use a metal part, as we can fit this part inside of the heel. We don't have to mess with the body construction, and it's very solid. So how does it help? How this system helps to you as a musician is that basically you can achieve better precision of the neck relief, and then if you achieve that fine setup suitable for you, it stays there much longer. Those are the two main reasons why we have developed this system. It's called CNR, Composite Neck Reinforcement, which is in all our guitars which have heel. So basically, how it looks then inside of the guitar of the neck. Here we have some sort of like a complicated slot cut by our special CNC machine into the neck. You can see in the detail, and this fits right in. You can imagine this one is glued together completely. It must be tightened with the wood, so we can influence how the wood will behave. Very important. So that's how the neck looks like inside. Now, then, if we have this part done, we will fit on the fingerboard. I will show you later how the fingerboard is done. We will fit the headstock and or head plate, I should say, and we can continue with manufacturing of the neck. Follow me. Yeah. So here is the neck. How it goes into basically with the truss rod installed, glued in. Here with the fingerboard on, and this goes into this machine over here. This is our 5-axis machine, and it basically manufactures the neck, shaping the neck from all sides. Basically, I will show you later what's the output of the machine, but it makes all the shape of the profile. It makes the headstock shape. It will even drill the holes for the machine heads and for the bolts, because we use bolts on neck. So it will do it in one operation, and this is possible because of 5-axis technology. I love this technology very much. You know, those 5-axis machines were my best kind of favorite toys, I would say, over here for many years, and I actually, you know, just to explain how the 5-axis technology works, because I think this could be very interesting for you. So Aleš, can you go with the camera to me? Thank you. So the 5-axis, you know the CNC machine. You might have heard about 3-axis CNC machine. So it has some sort of tool which goes in different different axes, like a X, Y, and Z. 5-axis machine has A and C axis, so it can basically turn itself and get to the neck to the different from different angles, and can therefore do a lot of operation at one time, which means we don't lose any precision with reclamping of the tool. And now we can use it, for example, here, because on the headstock we have a 15 degrees angle. So it can basically clean the headstock for us if we decide so, and so on and so on. As I said, the 5-axis CNC machines were my favorite toys. For me, I still do most of the programming myself because it's sort of my hobby. And why I say it used to be my favorite toys, because later, some years ago, I moved a little bit towards robotics, because this is of course natural next step from these these kind of machines. But what you will see here during the tour, you will see a lot of technology, and you will see a lot of hand operation from of our very skilled workers. And you know, these things have to go together in order to achieve like an exceptional quality guitar. I mean in terms of build quality, but I mean also in terms of sound quality, because those factors are very important for us. So it has to be latest technology, it has to be really old school handcrafting. This is what we do here. So follow me. I wanted to tell you a little bit about the fingerboards, because fingerboards are very important, especially for playability of the instrument. On the fingerboard itself, we go into the highest precision from the all other operations around the factory. These are under the highest precision actually. The reason is that you know, even 0.02 millimeter difference or imprecision would make a difference for your playability. If you have, for example, this fret just these small numbers lower than this one, and you play on this position, you would feel the bass. You wouldn't be able to do like a really comfortable string action and so on. And therefore we have to be very precise over here. The production of these necks actually are, or the fingerboard, is a lot of automatization because of this precision. We have some of the CNC machines, like over here, like the camera is watching right now. I can show you a little bit how that works. Basically, we use vacuum to clamp in the piece. We clamp in the piece of the fingerboard, and there is a special cutter over there, which looks like this inside. This is actually the thickness. We go for 0.252, and it goes through and cuts the slot for the frets. Now, why we do have to do this kind of precision over here is that you have to imagine that there are 20 frets over here, and then if every slot would be 0.05 millimeters thinner, and then we would press in the frets, it would be like about 1 millimeter of the material extra in this fingerboard, and what it would do is it would just basically bend the fingerboard like this, and therefore you would have it would be much more difficult to do precise neck relief. So we have to be very precise in this operation. And one small detail I wanted to show you is yeah, Aleš, thank you, Aleš. So this is the fret. This is Furch fret. We have a special material, Tonal, because it's very durable, very resistant towards oxidation and very resistant towards the wear from the string. So this is not a usual material on the frets, but we find this one is the best. And one German company actually is making it for us in the extreme precision. But what I wanted to show you is this tiny detail. This is you see that the leg is actually kind of like an undercut. You see the cap, but you don't see the leg going all the way through. Now on all Furch guitars, you never see the kind of like a T shape go from the side of the fingerboard. The reason is that we always fit frets like this. We undercut it, fit it in the fingerboard, and then we seal the rest of the material. I will show you on this one. Yeah, this is neck for the little Jane, and you don't see actually you don't see the T shape, the silver T shape, because it's sealed with a soft material. It's undercut. And therefore, if the neck guitars or neck or fingerboard shrinks in the low humidity, it basically doesn't allow the fret to go out of the side of the fretboard. And why we don't want that? It's quite obvious reason, because if the fret goes out, you probably know that feeling that it kind of scratches your fingers when you play, you know. And this doesn't happen if we do this kind of like this kind of improvement. And this is actually one of the philosophies we hold in the Furch guitars, because with the technology and with the way we are organized here, which you will see during this tour, we don't have so big trouble to make a 100% guitar from the production, but what we do care about and what we are interested in, how the guitar behaves, what happens to the guitar in 1 year time or 5 years time. This is what's interesting, and that's where a lot of our efforts in engineering and developing the guitar goes. Now you're only able to see the neck production, actually the neck sanding. I will show you. Yeah, this is a good example, because this neck in this state, this is how it goes out of the CNC machine I showed you earlier. So this is the result from that big chunk of the wood. The machine can carve this beautiful piece of ergonomic piece of the wood, which is great. So that's more or less about the neck production. And now we start with the bodies. So let's continue over here in this room. Ahoy. Mm-hmm. Sorry guys, I actually forgot one important thing. There will be a few points, one of which will be quite shortly in this room. I would like to let you ask some questions, and I will try to give you the answers. So please, during this live stream, even now, ask questions. I have Honza here, who is my assistant, and he will show it to me, and I will be answering. So please do ask questions. In the meantime, definitely. So I wanted to show you, or where we are right now is the room, which is kind of smaller room, where we produce tops and backs with its bracing. Now the room is actually smaller because we want to control the humidity in this room very precisely. You know, in a day we produce about 30 guitars, and each of these guitars could go to the different area of the world at the same time. So so it can go to the different humidity conditions, and at the same day could be very different conditions in Japan, where it could be, I don't know, 85% of humidity. It can go to the Norway where there is maybe 25 to 30% humidity, and we have to be sure that the guitar performs the best in these conditions. So that's why this room is very separated, and we are able to maintain the right sweet spot humidity. This is the beginning. So now I would like to show you how the top board looks like on the inside of the guitar. Top board is the single most important construction part of the guitar, influencing the sound. If you're talking about sound, this is the most important, as you see it right now. Basically, you can divide it into two parts. So one is top board itself, and one is bracing. So the top board of the guitar is basically behaves like sort of speaker of the or sort of membrane of the speaker. So it's basically making the resonance happen. This is the part of the top board, and in order to let me put it this way, it's made of wood. And wood, I mentioned earlier, it's quite unpredictable material because it's natural. Every piece is slightly different. You know it when you take the same model of same manufacturer and 2 pieces or 3 pieces of the same model. They can play very differently, and this is because of the wood. What we do in Furch guitars, we basically take every single piece or set for the top, and we let it go through the process of resonance, basically voicing. Voicing is a method where we measure physical properties and basically adjust these physical properties by changing the thickness of this top. Well, we can do it actually nowadays already independently to different areas. So you would, if you would take a gauge and start to measure here, you would have different reading here, different reading here, and so on and so on. And that's not a quality issue. It's actually intended to be this way. This is how we get to the kind of like, again, this kind of sweet spot of the sound we're trying to achieve. This is called voicing. We do a voicing on every single guitar which goes out of our production. From the Violet series up to the Red and Rainbow series, so Little Jane has this voicing applied, basses, and so on. Now, on the Red series and Rainbow series, for example, we do actually voicing of the back as well. So we have even higher precision of the sound quality output of the guitar. So that's about the voicing of the top itself. The bracing is actually a pattern, which you see, and the pattern it's always for one body shape. So if you have a grand auditorium or grand auditorium with cutaway, it would have not this one because this is dreadnought, but yeah, this is grand auditorium with cutaway. Oh yeah, I have a question here from one of the viewers. This is the bracing pattern of Little Jane. Looks simple, right? But it's cool about the bracing. The bracing is actually it looks simple. All of these braces looks quite simple. You know, you can sort of like kind of cut it from the wood and put it there. But the real magic happens actually where you cannot see it, because there are certain preloads, intended preloads, which we fit how we fit the bracing together with the top, and these are moving the sound in the direction we intended, and this is important to do. So kind of like a reverse engineering to just measure those braces and make a copy would not get you to the same result as with the sound. So so yeah, what I wanted to mention earlier, the bracing is always same for the body shape. Bracing has to be designed for the body shape. Now the backboard, you see one over here, it's actually quite easier to make, because the thing is that the bracing of the top has to hold the tension of 72 kilograms of the strings. It has to be stable. At the same time, it must not be too strong to kill the resonance, because we want the bracing to spread the resonance over the top. but it has to be strong enough to hold string action in a comfortable way, and it must not be changing itself because of humidity very often and so on. But the backboard is much more simple, so that's why even the bracing pattern looks quite easier than on the top. Now there is a question. Now we can actually I can answer some of the questions which there might have been. So Honzo, can you give me some?
Yeah, for sure.
Let's see.
So,
Welcome Honza here.
from which sources we got the wood?
What is it?
Yeah, from what country we use the woods?
Yeah, from what countries we use the wood. Basically, wood for our guitars are from all around the world. I have to apologize at this point because we were not able to show you the warehouse and drying cabins of the wood because we had kind of technical troubles with the Wi-Fi. So we could not bring you to our warehouse, which is in the next building. But anyway, I will explain. The top. And for top of the guitars, most commonly used materials are Sitka spruce and basically Western red cedar. Both are from North America. Back and sides, most common materials is Indian rosewood or mahogany, which can be, in our case, it's African. But there are a lot of, fingerboard. It's from Africa. It's African ebony. We have some parts like bracing actually comes from Czech Republic. It's a Czech spruce, but then you have a lot of exclusive materials, especially in our Rainbow series, where the material can come from Madagascar, can come from Australia, Hawaii, and so on. So basically, all around the world. Hanzo, do you have some other questions? Okay, super. Guys, please ask questions if you like. We will have another stop at some later time, and I will be answering whatever questions you might have there. So follow me. We will actually move now to a second floor. Actually, first floor. Now we are on the ground floor. You see the precautions actually of the coronavirus. So the handles here, or the handrails and doorknobs and so on, we sanitize 2 times a day. And of course, I have to wear the mask, and as all of our workers, this is a precaution which we have done. Actually, you can see all the team over here. We all have to wear the mask, but we want to keep everybody safe. It's important. So follow me to the first floor, where we continue with the production of the bodies. So the room which I brought you in is it's where we bend the sides. So sides come in a set like this. Actually, it's a nice book match set because it grows together in a tree like that, and basically you cut it open like that, and you have a very nice and mirror pattern over there. It's not so important actually here on the sides because here it's more like a visual thing, but on the top to have the mirror book matched pattern, it's because it also has a book matched physical properties, and for the guitar it's very important to have same characteristic physical properties on the left and right side of the top. Here it's not so important, but it's of course always looks very nice when the grain kind of comes together on the kind of end pin side of the guitar. or on the neck side as well. So what's a cool thing about this place and what happens here? It's that in order to bend the sides into kind of complicated shapes like this, or maybe into the cutaway shape like over here, and not to break it, you need to achieve certain state of the wood which is called plastification. It means that basically the cells of wood gets kind of flexible and soft, so they allow you to bend them, and then if you and then you know when you dry them, they stay in the shape. So how to achieve this this state is that you can achieve it with temperature. In air, you have to achieve the temperature of 240 degrees Celsius, which is very high. It's not very good for a wood to be in this kind of temperature. It already would burn. But if you use water for transferring the heat, you can only do 90 degrees to achieve this plastification. So we use water. We have a water bath over here. It's a kind of hot tub for the sides. And then after, let's say, 15 minutes, we take them out and fit them into the molds, which you see over here, which is already basically the precise shape of the guitar. Now the molds are heated, and they will basically evaporate the water out of the sides, and therefore you are not you basically go out of the rule by having the water there. And if you have just 100 degrees, you don't have the 240 degrees, which would be necessary for the plastification. So basically the wood starts to kind of harden and stays in the shape of the side. So let's move to another space here, another position. We of course have to put these bended sides into the forms, like you see over here. That's a dreadnought, and we have many different shapes. Actually, 12 different body shapes which you can choose from. You can see the line of our molds over here. So we fit that in. We glue tops and backs to it. And now it already starts to look like a guitar. You know, it's already. You can see over here. It's already familiar. It's already familiar shape. So we have a tops on, sides, back. Now next step would be putting the binding on. And in order to put binding on, we have to cut the slot. So I will show you how we cut the slot for the binding over here. Okay, here we have a robotic station where where the robotic arm can grab the guitar and go towards the milling tools, which you see back there on the pillars. And each milling tool is basically set up for different kind of binding. It can be set up for different kind of purfling and so on. We have a lot of different shapes, or a lot of different options there. And so by choosing the right program over here, the robot goes to the different positions and basically does the cuttings. Now the reason why we use robot here is that this is a very delicate operation, because you can do a lot of damage to the guitar. If you go too fast, maybe, then you will basically chip off little pieces of the wood from the top, and you have to change the top. And of course, top is one of the most precious material on the whole body. So so we don't want to do it. So that's why we have designed this workstation, where we use robot which can do consistent work, and it actually makes, because the precision of the slot is then so good, then the workers which then later do the binding, they have the body very well prepared, so they can do even their job easily and in better precision. So let's see if he can move it. Oh yeah. Yeah, I was saying earlier, these guys, these robotic applications became my favorite toys recently, because my first experience was back in 2017, where I was designing the polishing machine, polishing robotic arm. I will show you later, but those are next step from the Cnc machines, and it's very interesting to work with this technology. It's challenging, and but it's kind of my hobby, I would say. Alice, can we see something down there? Oh, okay, that's okay. So let's wait for a moment here. Yeah, it's already coming. Okay. Let's move on. Now, here in this area, we do a binding, and it's again a nice example. We have seen the great technology doing one part of the job. Now, if you follow me, you will see a other spectrum, other side of the spectrum of the production, and this is the handwork. The binding, it's not easy job to do the binding properly, because we use different materials, you know, wooden binding, koa, paduk, red heart, and so on and so on. And it needs to be precise. It needs to be nice. There must not be any gaps and so on. And so I have one of the most skilled workers over here to do the binding. But it's something which I don't see we will ever exchange it with some sort of automatization. Yes, robot can help with preparing the slot and so on, but then the person has to come and do this job themselves. It will always be like that. And that's what I like about guitar building. It needs this kind of blend of these two worlds. Yeah, Eliška is now working on I think it's a red series. Is that right? Yeah, it's right. Red series is our top of the line, basically. Voicing of the top, voicing of the back, and you can maybe see a nice purfling inside of this this abalone actually purfling over here. Okay, follow me on. When we finish the binding, we have to clean the guitar, and that happens over here. So this is all the cleaning of the binding itself, sanding the sides, tops and backs, where it's basically the preparation for the finishing. Finish spraying is upstairs. We will get there in a moment, but I wanted to show you one more cool thing. Aleš, follow me. Okay, here is our laser room. So what does laser do? You can have a look over here. It's in operation right now. So the laser is basically the technology which can cut the pieces of material like mother of pearl or pieces of wood, which we can then fit into the fingerboard or whatever other materials. Basically, what it does is cutting the material itself and cutting the inlay of it as well. So both these pieces are done with the same technology. You can see, yeah. There you can see how it's done by hand. The technology is actually capable to do a lot of like a detail work, like this kind of inlay design, which we have since 2012. It's you can see the amount of precision achievable over here. And the cool thing about laser is that actually you can personalize your guitar, because you can send us the drawing or picture of something which you would like to have in a guitar. We will prepare the design for you, and if you approve it and order the guitar, it's actually possible to fit in the guitar from the Green series and higher. This is possible. And yeah, this is actually another point where I wanted to answer some of your questions. So, Honzo, can you give me some? We have a question: how many guitars are you producing? We now produce about between 6,000 and 7,000 guitars per year. So basically, it means about 30 per day. That's our production. What kind of materials do you use for the binding? There are many options. There are some artificial materials like artificial turquoise, artificial ivory. Then there are natural materials. We have a koa binding, which is very nice, one of my favorites. We have paduk, we have red heart, we have rosewood, Indian rosewood, and yeah, and the maple and walnut. Those are the materials which we use. You can actually check it in our Rainbow series configurator. These options are written there, and with the pictures as well, so you can see how it looks like. Okay, let's go on then.
Yeah.
We will now move to at the second floor. So follow me. Yeah, it's a cool thing to see. This is actually yard of our factory. This is lovely day. Let us know how was the weather like in your place. But today in Czech Republic in Velké Němčice, it's a lovely day, and yeah, this is the yard of our factory. It's actually old mill house which my father bought about 20 years ago. It was in bad condition. He renovated it and slowly moved the production in here. So what I'm showing you was, of course, a long time kind of development of the situation, evolution of the Furch guitars. But we are very proud of having this place available and be able to work in this place. It's lovely. Follow me upstairs. Sunshine in Switzerland?
Yes.
That's good, thank you. So this floor, you can see here, it's all about finish, about spraying, polishing, everything related to finish of the guitar. Finish is, as I always put it, is the second most important construction element of the guitar, influencing the sound. You can improve the sound with a good finish, and you can kill the sound with a bad finish. Probably it's quite easy to imagine if you have a guitar and you put very big thickness of very soft lacquer on it. You can imagine it would kill the sound. On the other side of the spectrum, if you put very hard lacquer and very thin lacquer, you would basically improve the sound, and that's what we found out. If you want to improve the sound of the guitar, we have to find a very thin and very hard lacquer. So when we found this reality years ago, we started to look for the materials to use actually. But we had quite a bit troubles because a lot of materials which are used for in a guitar for a wood industry actually for spraying on the wood, they are actually designed for furniture makers, and they don't care so much about the resonance qualities of their product. So after some dead ends, well, I have decided to make this lacquer in-house. And yeah, that's our Easter decoration. I decided to make this lacquer in-house in Furch Guitars, and basically, well, it was going for about a year. After my office hours, I did go to the one of the spraying rooms over here, and I did mix the different additives together, did some test spraying, and so on and so on. And basically, over about a year, I was able to put together a formula of the lacquer which I was satisfied, and that's what you can see actually, what we have on our guitar since 2017, beginning of 2017. What is cool about lacquer? It's actually UV cured. And that's why it can be so hard and so good for resonance. Therefore, because the UV curing, basically, it's a different style of polymerization of the lacquer. It's a different way than the solvent lacquers do when they are curing, and therefore we can be about 2.5 times harder than any other solvent lacquer out there. So when I was developing this lacquer, of course, I realized quite quickly that it's okay, it's hard, very good, but then if I wanted to polish it, it of course took me also like 2.5 times longer, because it's 2.5 times harder. Now, before, it took my guys about 1 hour to polish a guitar. Now it would be 2.5 hours, and it's you have to imagine it's quite difficult job. You know, it's heavy on your back. It's not easy job. So I tried to put together a kind of solution that that would implement automatization. So here actually you can see the result of it. We have a robotic hand which can grab the guitar and can go around these polishing wheels you see there and polish the guitar. Very important thing is that there is a pressure sensor on the robot, so we can feel how much pressure it applies towards the body, and from different angles as well. So that makes it actually, well, without that sensor it would be useless basically. But I spent about 3 months of programming this machine, and then my goal was to reach actually better quality than a human hand can do. It's possible. I knew it's possible, and trust me, it was a tough job. I hit some dead ends there, and you know, to be honest, at some points I was thinking that I would jump out of the window. But anyway, I did it, and at the beginning of 2017, I was able to put it in the production like you see over here. Yeah, this was my first experience with robotics. Yeah, it was challenging. Now, about spraying itself, I want to show you how guitars are sprayed nowadays. Because the spraying, in order to achieve the great quality of the surface and small thickness at the same time, we have to put a lot of layers. On a Furch guitar, if you have a full pour finish, we have to put 9 layers of the lacquer. It's not just 3 or 4, it has to be 9. So here we have a robotic application of the lacquer as well. You see there is a robotic arm which grabs the guitar and sprays it, and then let the guitar to be cured under UV light, and so on and so on. The reason why we use machine, I have to tell you a little story about it, because spraying, it's honestly my most I like this job the best from all the other jobs in the factory. The thing is that you have to develop a feeling. When you are spraying something, you have to develop a feeling, because you usually know maybe another day or another 2 days later if you've done the job properly or not, because that's how the spraying works. So it's not like just taking a chisel, you make a cut, and you see immediately if you've done good or not. But with the spraying, it's more difficult. I tend to think that I'm quite good in spraying, but even for me, when I was training my people to put on a resonance enhancing finish on the guitars, I had to do like 12 guitars in one time, you know, and it takes about 2.5 hours, and then I was not able to make the same quality for all of them, and the quality is important. So so therefore I started to think about, okay, we have to figure out a way how to make it some sort of automatized, because the quality is important there. Well, of course, it's not a nicest environment in a spraying cabin, so I believe my workers are also happy that they don't have to do it anymore. Yeah, that's our spraying. Resonance enhancing finish, very important feature of Furch guitars. So now let's move on to the third floor, because we are getting to finish now. Yeah. Sorry, technical pause. Watch your head guys here. It's an old building, so we have lower ceiling. Jsme tady, ahoj. So here in this room, and we are really getting to finish, as you can see. You can see guitars almost put together. So in this room, we of course get the bodies finished, get the necks finished, and we have to put them together. Now, in order to put the body and neck together, we have to follow certain rules in geometry. So basically, the flat of the fingerboard has to be has to point to certain height over the top board in order to guitar to be basically possible to set up with a precise setup. So you know, it used to be done by very much by hand. So we were basically cutting this area, attaching this to body. Then we looked at it, see where we are with geometry. On the first time, you never do it right, so you take it apart and then redo the step until you reach the precision you need. And this is actually quite a dangerous operation, because you can imagine guitars already have a lot of work on them being done before, like they are finished, you know, they are nearly in the final stage. And so every manipulation is basically potential danger of damaging something, and that's basically the risk of having very expensive repair there. So, of course we try to figure out how to make it more precise, and so we don't have to do like a 5 times operation, just 1 time operation, so we can be sure that it goes together very well. For that reason, we actually cut a very precise shape of the heel down on the big 5-axis CNC machine. It's done with a precision of actually was able to 0.03 precision over here. And then we of course cut this area, the back of the heel, with the same technology. So we have the angle relative towards the fingerboard, very fixed. And here on this top floor, when the guitars come here, or bodies come here finished, then we fit the body into special template, which already has the geometry kind of preset in it. We fit it into special CNC machine, and it cuts the slot actually like this one. It cuts the slot like this one. So it's already geometry. The geometry is already in there, and then we can actually fit the neck to it, and it's 100% perfect. So that was a big step forward, because of course you don't have to move the necks and bodies here and forward, and the precision is very high. Now, when we have these necks and necks and bodies together, we have to put on a bridge. So this is the bridge. Bridge has to be glued always wood on wood. We don't glue the bridge on the lacquer because it would go off easily. So we have to take away the lacquer in this area, and we have developed a special CNC machine actually that follows the, basically I show you on the top rather. It follows the curvature of the top because every top is slightly arched. So it follows this arching and cuts only as deep as this as we want it. And on the other side of the bridge, the connecting part of the bridge, this is you can see maybe a small slot over here on the side, on the edge. And this is done with the same technology. So when we put it together, it fits precisely together, and we have therefore very good contact, glue contact on the bridge. So if you imagine again 72 kilograms, there is big torque tension on the body and on the bridge actually, and that's why we are we go into so big detail in gluing the bridge on the body of Furch guitars. Yeah, one more thing which actually it reminded me just now when I was holding the bridge, because this is actually the bridge for the 12 string. You might know the problem generally the problem of the 12 string, that you always have to have a kind of big bridge. You know, this is common solution, that you have a big bridge because you have to fit 12 bridge pins in, and they cannot be next to each other. They must be offset because they are just too big. But if you offset the bridge pin, then you basically make a different break angle of the string. And different break angle of the string over saddle makes a different behavior. It's a tiny detail, but you can really hear the difference. And what we have done here, Alex, maybe you have a look over here. I still need to. If you look what we have done, we have standard 6 holes for the bridge pins, yeah, and then we have a channel. We have a channel where when the coupled string goes through, and basically it emerges in the same break angle as the other one, and so therefore we don't have any different behavior of the coupled string. This is just a small detail. It's on our 12-string guitars and 9-string guitars, and well, it's also possible to do this because of the technology which we have. Because to do it by this kind of construction by hand, it's not easy. Oh yeah, we have a question. Why aren't you gluing the bridge before spraying? The reason is that it would not look great because the lacquer would make basically small kind of, how to call it, in a ramp over here in the edges and so on. It would look kind of cheap. We want the bridge to be glued later, after the finish is done. Okay, so let's go. Let's go to the really final stage. Tak díky, ahoj. So here we are at the final stage, as I said. So the guitars, necks, bodies attached together, bridge is glued on. Guitars come here, and we do just a final setup. So we will fit a saddle, we will fit a nut, pull the strings on. We fit a pickup system if it's ordered by the customer, and what we have to do is basically get the guitar into the factory setting. We have certain rules what we want to achieve on the guitar, we want the guitar to be as comfortable as possible when it arrives to the customer, and so there are these rules. My guys over here have to basically get to this precision, and yeah, when they are done, we do a quality check, output quality check, and we clean the guitar and pack the guitars, and we will move them actually to the next building where we have an expedition warehouse. Now I reminded me, I was talking about quality check. We have a quality checks on 7 different positions throughout the production. So that's where we actually check various aspects of the part which is being checked. It can be inlay design if it is right. It can be if the material is right, if dimensions, of course, and so on and so on. Well, also, you might have noticed somewhere in the production that there are barcodes coming with the guitar, actually, when the guitar is going through the production. And the barcodes are there, so we can track every single guitar where it's going through the production. And we can actually, we have the history of the guitar, so even if we receive the guitar for the servicing and so on, we record this, and we have basically sort of like a birth list of the guitar. Oh yeah, we have a question here. What brand of strings you use? We are using Elixir strings. Elixir Phosphor Bronze on our color series, Elixir Bronze on a vintage series. Yeah, there is kind of notice a lot of women work. It's actually quite interesting because you might have seen that there is a lot of detail work in the guitars, in building for guitars. It's a lot of detail work, and in our experience, women actually has well better kind of how to say, well. Yeah, they have definitely better kind of sense for the details, and you know, my experience with guys, they're good with a very tough job, but girls can do better precise job in general, of course. It's not. It means in general.
Last
one. Yeah, there is a question. How exactly do you measure the tonal quality of the wood grading? Okay. The grading is done actually more like visually. Every manufacturer or every supplier does the grading visually. So we have a AA, AAA, and master grade quality. Those we check visually, and then when we pick the wood for the specific guitar, well, we have already pre-graded into this segment, so we know that for the red series or rainbow series we have to pick from the stack of the master grade, then and so on. But the tonal quality, which is mentioned in the question, it's basically we don't pick it. We actually make the wood behave as in a good tonal quality by the voicing, because. To be honest, in my experience, I know that even from the B-grade material, we can produce a really high-quality sounding guitar. So the voicing actually and the construction is in that way more important than the wood itself.
Maybe you could put an elixir on the guitars instead of.
There is also a good question. Maybe, maybe put a 13 elixir string on the guitar instead of 12, without damaging the guitar. Actually, the guitar is tested with a 12 string, 12 set. But it's definitely possible, and we have in our warranty conditions that you can put up to 13 strings on. So okay, let's take a look like Mark is doing his check. And if in the meantime, if there are any questions, I would like to answer those.
Can we hear the final product?
Yeah, can we hear the final product? Yeah, Marek will play it right now. Yes, play please.
Akusticky nebo elektronicky?
Acoustic. Thank you, Mark. So okay, that's it. That was a kind of fast tour through Furch Guitars, and I thank you very much for joining us. I wish you stay safe, stay healthy, and I hopefully see you at some of our other streams, whatever is out there. So thank you very much once more, and have a great day.